Hello everyone, my name is Audia Vicenda and I'm here today to explain my WebGIS applications that I built using Supermap iserver and Supermap iClient and also the PostGIS database, which is the extensions of PostgreSQL that can consume the spatial data and storing the spatial data. And first thing that I will explain to you is the purpose of my applications here. The purpose of my application is to monitor the flood frequencies in DKI Jakarta, the capital city of Indonesia, and it will be useful for government institutions to monitor the flood frequencies in certain area in some village inside the DKI Jakarta area real time or by day, by week, or by month. That's the main purpose of my applications. And next I will explain to you how I build these applications. I built this as applications using iserver. This is my local host of iserver manager, and you can see here that I have uploaded some of web service or WMS of my spatial data. It consists of the water gate and water pump locations and also the full attribute of the spatial data and also the river locations and the village area of the DKI Jakarta area. And then I built it using iClient, and not all of the iClient feature that I use here, but some part of it, which is the leaflet part, because the leaflet JS is the common language that I usually use in my previous project. And this is the part of my code, which is almost all of them built using JavaScript, leaflet JavaScript here. Some of them using the native leaflet JavaScript language, but most of them I built it with the combinations of the Supermap library. Okay, and next I will explain to you what my applications can do. First, my applications have abilities to control the layers, the visibility of the layers itself. Like we can change the base map here using a Google base map or the OpenStreetMap base map. The current base map here that I use is OpenStreetMap base map. This time I will change it to Google Map Satellites. Okay, it loads, and here's the view of the layer of the Google satellites, and I will change to Google Road. Okay, this is the Google Maps base map. Sometimes it's hard to load. It depends on the connections that we have. Okay, that is the base map control, and this is the spatial data control. I will show you how I add and remove the spatial data of water gate and water pump here. I divide my water gate and water pump based on the height from the ground. So there is some classifications here, some filter here that I use. It depends on the height from the ground, like this one. Okay, and this is above 2 meters. This is above 6 meters. This is above 10 meters, and this is above 14 meters. That is about the layer control, and the code of the layer control, I will show you here. The layer control code can be seen in this part. I'm using leaflet layer control, and I use CSS code to make it prettier and eye-catching. This part is the code to gather informations of all spatial data inside my WebGIS applications. And the next features in my GIS application is the locator functions here. If I click here, it will show the current locations where I stand right here. It may take a while. Okay, this is my location right now. It's my home. It's far away from Jakarta. Okay, I'm gonna zoom out and extend it to the layers, the previous visible screen, to DKI Jakarta. Okay, back to Jakarta again. Okay, this is Jakarta area, and the next function, the next feature that I add in my WebGIS application is the minimap. The minimap show us the bigger screen, the overview display of our current extents here. So we are currently viewing the Jakarta area, the capital city of Indonesia. And next, the fourth functions that I add into my WebGIS applications here is the functions of highlighting the feature that I click, that I choose, like this. It changed the color of the feature that I click, that I hover over it, and the informations right here is also changed based on the attribute of the spatial data that I hover at, like this one. Its name is Pademangan Timur, and it has 25 times of floods per year, and the maximum heights of the floods that was recorded was 1 meters. And right is Gondang Dia, which has 27 times of floods per year, and it has 3 meters of height, of flood height. The maximum flood height here is 3 meters. Okay, that is the highlight features, the highlight functions, and the code. I'm going to show you the code here that I use to make my map eye-catching and informative. Sorry. This one. I call the layers and I change it using I change the styles using CSS script, and it will change if I move my cursor. Depends on the spatial data that I hover at. Okay. For your informations, all the data was stored in Supermap iserver. So I am just call the data using the GeoJSON extensions or the XML extensions that was given from Supermap iserver. Okay, and then the next feature is the pop-up. The pop-up of the spatial data, the pop-up of the Watergate. This one, I will give you an example. The pop-up here can accommodate the photograph of the locations on the field, and I make it like in a carousel styles, and also in the pop-up I add some code to make the attribute value visible for the users, like this one. Location undefined, the height 3 meters, the class is the first class, and the years made 1985, and the VRMS during the survey is 0.0001. Type of survey undefined. Then next function that I will show you is routing functions. The routing functions is able to give us the informations of our current locations and the fastest route to reach the chosen assets in the field. I'm going to show you how. I will turn off the unnecessary layers. Okay. River. Okay. To open up the console, we need to double click on the features, and it will give us the options: start from this location or go to these locations. So this is how the routing functions work. We double click it, start from these locations, for example, and choose this one, go to these locations. So it will give us the directions, and the descriptions here is the guidance, turn-by-turn guidance, but I don't think this is really necessary because we can see it directly inside the web map applications. I'm gonna show you the others example. Okay, right. Okay, go to these locations. Here it gives us another directions, the closest path to reach the chosen destinations. I am using the Supermap route finder to make the polyline that create the path here, but the geocode database of the Supermap in Indonesia is currently still, I think it's still in development, so it doesn't have a complete address of the Jakarta area, so I'm using the database, the road and the location database from nominating OpenStreetMap. But the engine to create the root layer here, I am using the Supermap root locator service, like this one. Okay. Next, I will show you about the functions, the dynamic legends, like this one. This legends is a dynamic legends that I built using a DOM event, so it can change depends on the attribute of the spatial data. Okay. Show you the code, like this one. The legend here, it's supposed to be dynamic. So if I change the value of a certain spatial data here, so the legend will automatically, by using the DOM event inside my JavaScript code, I can change the value, the symbolization here dynamically. Depends on the value of the shown spatial data in my WebGIS applications. So if I change a certain features of spatial data here, this legend will be dynamically change the value itself. If I delete all of the water gate which has the heights lower than 2 meters, so these legends will be empty and will not be shown in the applications. Maybe that's all of the explanations of my WebGIS application that I built using Supermap iserver and iClient's JavaScript. Thank you for watching, and